In this video, I'm going to be solving this word problem which involves patterns. Every day, Carmela sees a different number of bacterial colonies, and I've already started to make a little bit of a table here, a little bit of a chart, the day that we're at and how many colonies she's seen. 1 on the first day, 4 on the second day, 9 on the third day, 16 on the fourth day, and we're assuming that this pattern continues over the next several days. We want to know what kind of sequence are we talking about. Is this arithmetic? Is it geometric? Is it none of the above? And assuming the pattern continues, how many bacteria will we expect to see on the 10th day? So I'm looking at my sequence of numbers, 1, 4, 9, 16, and I can say right away that it's not arithmetic. Remember, for an arithmetic sequence, we would be adding the same amount each time. Here, going from 1 to 4, you would be adding 3. To go from 4 to 9, you would be adding 5. Already I can stop and say, since that's not adding the same amount each time, this is not an arithmetic sequence. It's also not geometric, because for geometric, we would have to be multiplying by the same amount each time. To go from 1 to 4, you would multiply by 4, but going up from 4 to 9 is not multiplying by 4. That would be multiplying by 9/4, which is not the same thing. So it's not arithmetic. We're not adding the same amount each time. It's not geometric. We're not multiplying by the same amount each time. Therefore, it's neither. Now, as far as the question of how many colonies will Carmela see on the 10th day, this is where we need to start to think about what kind of pattern is underneath these numbers. And maybe we might have already spotted the pattern when we thought about addition, that on the first day to the second we went up by 3, then we went up by 5, then we went up by 7. So we can kind of make a guess here that to go from the 4th day to the 5th day, notice each time we're going up by an odd number, by 3, by 5, then by 7. So it would make sense that if the pattern continues, we would go up by 9, which would get us to 25. And to go from day 5 to day 6, we would be going up by 11, which would give us 36. Then from 36, going up by 13 to get us 49. From 49 up by 15 to give us 64. And to go from 64 up to the next number, we're increasing by 17. That would be 81. And to go to the last day, to the 10th day, going up by 19, which would bring us up to 100. So my answer then, how many bacterial colonies will Carmela see on the 10th day? My answer then for that is 100. Now that's one pattern that I could have noticed here, going up by 3, then by 5, then by 7. So imagining that each time I'm going up by an odd number. I could have also noticed that this is a pattern where the number of colonies is a perfect square. On the first day, she saw 1, which is 1 squared. On the second day, she saw 4 colonies, which is 2 squared. On the third day, she saw 3 squared. And on the fourth day, she saw 4 squared. I could have, if I had noticed that these were all perfect squares, made the prediction that on the 10th day, she should see 10 squared, or 100 bacteria. For sequence problems, there's often more than one possible way that we can find the pattern. So the patterns here could be that we're increasing by odd numbers, or it could be that the numbers of colonies are perfect squares. Both are patterns describing the same sequence of numbers.